This segment is on prime factorization. So I've already got a definition up here for you. What prime factorization involves is taking any number, right, and breaking it down into the product of primes. Okay, so I'll give you a second to write that down. Right, and the other day we were listing factors, okay, writing that list of like 1 comma itself, 2 comma, 3 comma, and so on. That's finding factors, right? That's a little bit different than prime factorization. So let's actually look at some of the same examples that we did yesterday, all right, when we were listing factors, okay? So what you would do, and there's a couple different approaches that I've seen taken. What you would do is break this down, and let me just review the first few primes. Right, we're going to actually have a whole lesson on primes coming up here, but first few primes that we've got 11, and then the next one will be 13. Okay, so we're going to be breaking our numbers up into products of these. So what I always tell students to do is find any pair of factors, right? And then just keep on breaking these numbers down until you get to primes. And I used to always tell my students, when you get to a prime, circle it, right? When we recognize we're at a prime, right? And then 8 breaks down into 2 and 4, 2 is prime. And sometimes I see this done like in a tower, like where you're only dividing by primes though. Don't divide by anything other than what's on this list if you're going to use the tower approach. And then what happens is on the outside, I've heard this called the birthday cake method too. What you'll end up with on the outside is all of the prime factors. So you do this however you choose, right? If you want to use this birthday cake method or make the tree. And typically we list these in numeric order, and it's acceptable to write it all the way out like this. So let's see, we have 3 2s and 2 3s. All right, and those are dots in between for multiplication. Oh, wait. Where's my little eraser? Oh, wow, I erased my writing too. I don't think I meant to do that. Go back to this. Okay, no, I'm still on eraser. Hang on. Line, draw. There. Oh dear. Let me try this one more time. Draw, line. There we go. But typically we write it with exponents, right? That's a more common way to write that. Okay, so this would be the preferred answer. Okay, and so it's saying every number can be broken down into a product of its primes. That's also why we will call primes the building blocks of all numbers, because if we break all numbers down into primes, on the flip side, we can build all numbers up from primes. Okay, we'll look at that in a minute. So why don't you try doing a prime factorization on 30? It should not be terribly difficult. Okay, so 30 can be broken up into 2 times 3 times 5. And here's where I want to make the connection between the prime factors and divisibility. Okay, so let's write this down. Let me open a text box and state that a number is divisible by any and all of its prime factors. And also by all combinations of its prime factors. Okay, so what I can do is create any combination that I want from these prime factors, all right? And I know how to do systematic lists from a prior lesson. So if I were to systematically start grouping these up, I could say, well, one grouping I could make would be 2 with, and then put the 3 and the 5 in a group, right? In other words, this would be 2 and then 3 times 5 is 15, right? Or I can group the 2 with the 5, right? That would leave 3 like on the other side, right? And this would be 10 times 3, right? This would be 2 times 15. This would be 10 times 3. Or the other possibility of a grouping is the 3 with the 2, and then leave the 5 alone, right? Which would be 6 times 5. So what I just created here is a list of 2 times 15, or 2 and 15, right? These would be factors. 10 and 3 are factors, right? And a factor is another word for divisor. And then 6 and 5. I'm sort of out of room here, but 6 and 5. And that's what we listed the other day as factors of 30. So what that means is that if I gave you a number like this, and let's not do any crazy thing like reach for our calculator, okay? Because if you put this into your calculator, this is a huge, huge, huge number, and it would give it to you in scientific notation, right? And we don't need to put it into our calculator to find what divides it, okay? So if I asked you to list for me some numbers that divide this. Let's call this n, so I can give it a name. All right, what are numbers that divide n? Okay, and the most obvious numbers that we could say that would divide n would be 2, 5, 7, and 11, okay, because it's divisible by all of its prime factors, but then it's also divisible by every combination of its prime factors. So I could start combining. 2 times 5, that's 10. So this number would be divisible by 10. It would be divisible by, I could put 2 and 7 together. It would be divisible by 14, by 22. Right? Then I could combine the 5 with any of these other things. So like 5 and 7 would combine. So this number n is divisible by 35, by 55. And then I could put the 7 with the 11. This number n would be divisible by 77. But then I can also notice these numbers are to powers, right? So like I could say, well, this number would have to be divisible by 4 because it's got a total of 3 factors of 2. It would be divisible by 4. It would also be divisible by 8, right? So like I could do these powers out. It would be divisible by 25. Oh, I don't feel like raising 7 to the 4th, but how about I just square 7? That's 49. This would be divisible by 49. It would also be divisible by 7 cubed. Actually, 7 cubed is 243. I know that one. I don't know 7 to the 4th off the top of my head. I mean, I'll just put 7 to the 4th in my list. And I know 11 squared is 121. But then I can start combining things. right? I could say, well, this is 8, and I could do an 8 times a 5, right, to get 40. Or I could do a 4, right? This contains 4. I could do a 4 times a 7 to get 28. I could do a 4 times 11 to get a 44. I could do a 2 times a 7 squared, right? A 2 times a 7 squared. 7 squared is 49. 2 times 49 is 98. Like, I can make any combination. So I can find tons of possible things that will divide n. All right, so you try this one. Let's call this K. Let's make it 3 to the 4th times 7 times 11 squared. This won't have quite as many answers as the last one. Okay, but list for me, other than 3, 7, or 11, try listing like 5 other numbers that will divide K. Okay, so pause the video and try that. Okay, so if you're back, 3, 7, and 11 are the most obvious divisors. Then we can look at any combinations. 3 with 7, so 21 would have to divide this. 77 would have to divide this. 33 would have to divide this. Start looking at these powers. So 3 squared is 9. 9 would have to divide. 3 cubed is 27. 3 to the 4th is 81. 7, or let's see, we've just got 7 to the 1st. 11 squared is 121, but then I could take any of the powers of 3 and combine them with the 7 or with the 11. So I could do 9 times 7 is 63. I could do 9 times 11 is 99. The rest of them are so big I can't do them in my head. So I'm going to stop with these because I told you to list 5 factors. I hope your 5 answers are something on this list. Okay, just one more thing that we do before we end. So I had said that primes are the building blocks of all numbers. If I wanted to give an example of a number with 3 prime divisors, right? I can build my number up from the primes. Okay, so we have an exercise in a minute where we're going to look at all the primes, starting with 2 and going through 100, but here's the first few, right? If I want a number where I have 3 prime divisors, okay, I could just pick any 3 primes from this list and I could multiply them together. Right? Like this would be, let's see, I can do this in my head because 21 times 5, right? That's 105. All right, so that would be an answer. Or, 2 times 7 times 11. So let's see, that's 22 times 7. And that would be 154. Okay. I could also raise these to any power that I wanted, right? And combine them, right? If I want my number to have 3 distinct prime divisors, if I used a 4, right? If I did 4 times 3 times 5, right? This number, which would be 60, right? It would have the prime divisor of 2, 3, and 5. These would be 3 prime divisors of 60, right? I just happen to pick a higher power of 2, but it still makes 2 a prime divisor because 2 is contained in 4. So I think that should do it for this segment. We'll pick up with some more discussion on primes.